Hello dear students, I welcome you to my this video channel. I am Dr. Yusuf Hanif Sheikh, Associate Professor, Department of Physics, Shivaji College, Kannada. Today I am going to teach you viscosity part first. In my today's lecture, I am going to cover introduction, streamline motion and rate of flow, and equation of continuity. Introduction. Viscosity is the property of the fluid by virtue of which it opposes relative motion between its different layers. For example, liquids and gases exhibit viscosity, but liquids are much more viscous than the gases. Viscosity is the resistance to movement of liquid. Water flows fast, so it has low viscosity, whereas honey has a high viscosity. If the liquid is at rest, the hydrostatic pressure at any point inside the liquid is given by P is equal to H rho G. However, when the liquid is in the state of motion, a fluid in motion possesses various forms of energy such as kinetic energy, potential energy, and gravitational energy. Streamline motion and rate of flow. Let us consider a liquid flowing through a pipe line where V is the velocity of liquid flow and small a is the area of cross section of the pipe as shown in figure 3.1. Here the volume of liquid flowing per unit time is equal to volume upon time, where this volume is equal to this length into area upon time t. Now this length is equal to V into t and multiplied by area. Here t gets cancelled and here remains only V multiplied by A. It can be written as A multiplied by V, where A is area of cross section and V is velocity of flow. The flow of fluid is said to be steady, streamline or laminar. If the velocity of the fluid remains constant at every point in the fluid, the energy required to flow the fluid is used up in overcoming the viscous force between its layers. In steady or streamline flow of a fluid, particles of fluid move one after the other in the layer, with their velocities constant at the various points on it and directed along the tangent to these points. The flow of fluid is steady or streamlined if its velocity does not exceed a limiting value called its critical velocity, beyond which the flow loses steadiness and becomes zigzag, called as a turbulence. For laminar flow, Reynolds number capital R should be less than 2000. According to Reynolds, critical velocity of a fluid is given by Vc is equal to R eta upon rho capital D, where this R is a Reynolds number, this eta is the coefficient of viscosity of the liquid, and rho is the density of the liquid, and D is the diameter of the tube. Now, equation of continuity. Let us consider a horizontal pipe as shown in figure 3.2. If a fluid is flowing through a pipe is assumed to be streamline motion, then the area of cross section at A is equal to A1 and area of cross section at B is equal to A2. Therefore, A1 V1 is equal to A2 V2. This equation is called as the equation of continuity. Generally, AV is equal to constant. And thank you, dear students, for your patient listening. See you again in the next video. Till then, bye bye. Take care.